Hi everybody, thanks for watching. In this video we're going to take a look at some sample questions that require the use of the half-life concept. So for our first problem, we'll start with a pretty easy one. And my first recommendation before we even start to read through this guy is whenever you do these word problems, it's always a good idea when you read it through the first time to circle or highlight or underline anything that is going to be important information that you'll likely have to use later. Such as in the first sentence, it says nitrogen-13 emits beta radiation with a half-life of 10 minutes. I'm going to circle the half-life of 10 minutes because in a half-life problem, it's a pretty good bet that you're going to have to use that number. The next sentence says if you began with a 2-gram sample, that's going to be important. You always want to know your initial starting mass. I also like to circle when I find what the question is asking me for, and it says how many grams. So I'm looking for a mass when I'm all done with this. Would remain after 3 half-lives, and that's going to be important too, the fact that we're waiting 3 half-lives to see what mass remains. Now the next thing I recommend to solve these is once you've got all your important information circled is create a table just like we saw in the last video and that we practiced today in class. For this table it should look something like this. So I always start the table with how many half-lives have passed, total time that's passed, and the other columns or rows can be really anything the question is asking about. Since this problem is asking about mass, grams, I probably want a row that will tell me how much mass is left. And then you start filling it in. The first column should always be 0 half-lives. That's when kind of nothing has happened yet. There's been no decay, so 0 time has passed. That's also where the initial mass of 2 grams, in this case, is going to be written. And then after that, you would go to the next half-life. The problem tells you that a half-life is 10 minutes. So my total time now will be 10 minutes. And remember, the concept of a half-life is every time a half-life passes, the mass splits in half. So 2 grams simply turns into 1 gram. And then obviously, since the question is asking about how many grams after 3 half-lives, go ahead and keep doing this same thing in the table until you're up to 3 half-lives. So after 2 half-lives, 20 minutes total has passed, and the mass splits in half again to 0.5 grams. And after the third half-life, an additional 10 minutes means 30 minutes has passed, and the mass splits in half again until there's only 0.25 grams left. And the table should leave you with everything that the question asks for. 1, how many grams would remain after 3 half-lives? That's 0.25. And the second question, how long would this take? The answer would be 30 minutes. Here's our second example. Just like always, it's a good idea if you pause this and try it on your own first. I've got a kind of pre-made table set up here to be a little bit neater and save some time. It's got pretty much the same rows from the last example for you to use if you need. So let's do what we did in the last example. Start off and circle everything that sounds important. It gives me the half-life of 2.6 hours. Gives me an initial milligram sample where I start of just 1. It also gives me a total time in this problem of 10.4 hours. That means the elapsed time is going to be 10.4 hours that we're trying to reach. And remember that first column should always be 0 half-lives have passed, meaning 0 hours have passed and elapsed time. If we fill out the mass left, it's just going to be the 1 milligram sample that we started with. I'm actually going to ignore these last two because the problem isn't asking about them. It's just asking what mass of manganese is left, so let's not waste time and fill those guys out. So the next column, after 1 half-life has passed, which takes 2.6 hours, my mass splits to 0.5 milligrams. And after 2 half-lives have passed, another 2.6 hours brings us to 5.2 total hours, and the mass splits in half again to 0.25 milligrams. 3 half-lives brings me up to 7.8 total hours, and I'm not at 10.4 yet. My mass splits in half again to 0.125 milligrams, so I have to keep going. And then finally, at 4 half-lives, we reach the 10.4 total hours the problem was asking about to begin with. And the original question was what mass of Mn is left. So my final mass, 0.125, split in half, so divide by 2 is 0.0625 milligrams left. And one final example for the video involving cobalt-60. This one's a little different. It says the mass decreased from 0.8 to 0.2, so it's giving you the final, or the initial and the final mass in a total elapsed time of 10.5 years. The question in this case is asking to find the half-life itself of cobalt-60, but using the same kind of table setup, we'll answer pretty much any of these questions. The first column, 0 half-lives have passed, 0 time has passed, and the initial mass, which it does give you as 0.8 grams, so you can go ahead and fill that in. And just like always, we go to the next half-life, so 1 half-life has passed, means the mass splits from 0.8 in half to 0.4. The only difference is we don't know the elapsed time. It doesn't give us the half-life. That's actually what we're trying to find, but you can treat the table the same way. So let's just keep going with that. After 2 half-lives, the mass splits in half from 0.4 to 0.2, and you should recognize that you've reached the point that this was describing. The mass decreased from 0.8 to 0.2 grams, and it gives the total time that took, so it gives us this box as 10.5 years. So we can go ahead and fill that in. The only other thing to think about is, to answer the question, what is the half-life? Remember, half-life is just every one of these jumps. So if 2 half-lives took 10.5 years, just divide that in half to figure out what 1 half-life is. And half of 10.5 should be 5.25 years for the final answer. And that concludes this video. Thanks for watching.